Hello girls, today I'm going to teach how to interpret graphs. This is a very important knowledge because when you're studying science subjects, there are lots of chances that you come across with the graphs in the exam papers. So now, let's see how to draw a graph first. So usually when you have face a problem, like plot a graph to see how the relationship between the temperature and the reaction rate. You have lots of temperatures, say in the reaction, you test 10 degree, 20, 30, 40, 50, and then you have got the relative reaction rate of them. But then the only problem is how do you define which one to put in the x-axis and which to put in the y-axis? Do I need to put the temperature in the x or y-axis? And how about the reaction rate? Now let's see. Actually, there is a rule. That is, you have to put the independent variable in the x-axis and the dependent variable in the y-axis. Mind you that if you have forgotten already, that independent variable means the things that you change. Say, if I'm doing this experiment to see the relationship between the temperature and the reaction rate, then I have to change the temperature. I changed it from 10 degrees to 20 to 30, and then I test their reaction rate and measure the reaction rate. Of course, the dependent variable here is the reaction rate, but you do not measure the reaction rate by like using a meter. Maybe it is amount of product form, okay, of products. Then this one is the dependent variable. So next time when you plot graphs, you make sure that you know which one is the independent variable, and it should be put in the x-axis. And usually, for the independent variable, which is something that you can control, they increases steadily. For example, when I say temperature, maybe I have 10 degrees, and then 20, and then 30, and 40, and so on. So this one, it increases, each blank increases by 10. So when I measure 10 degrees and then I plot a graph here, and then 20 degrees plotted here, 30 plotted here, after I had measured the reaction rate, of course. And then for 40 degrees, because it had already reached the maximum temperature, the optimum temperature, and then it starts to drop. So this one, for the dependent variable, you usually cannot know how it will change. For example, in 10 degrees it is here, it is well it's okay, and then 20 degrees it increases. For example, here is 10 and here it is just 15, it increases by 5. From this point to this point increases by 5. But 30 degrees, because it is the optimum temperature and it increases so much, here it is 30. So it increases by 15, and then the next point it drops back to 10. So this one, for the dependent variable, usually are points that you don't know how they change. This moment they increase so much, and the next moment they drop so much. So here we put the dependent variable, some things that we might measure, and we cannot predict how they change. For the independent variable, which is something that we control, we change during the experiment. Usually we put it in they increases in scale. Okay, so like this one, this is the increasing enzyme activity. The picture that I draw, just like it, we have the temperature here and an enzymatic activity here. You can see the curve increases. Points that you plotted here, but for the y-axis they increases by the amount that you don't know, you cannot predict. So bear this in mind. X-axis for independent variable that you change, y-axis for something you measure. Like here, growth of a population over time. So if you want to measure the growth of population over time, so you measure the time as the independent variable, you change the time in 2001, 2002, 2003, and so on. Changes 1 year after 1 year, increases steadily. But the population size is something that you cannot control. You can see here increases so slowly and suddenly it goes so high. So this is an example. Another example, substrate concentration versus rate of reaction. You want to see how substrate concentration affects the reaction rate. So you change the substrate concentration. Substrate is something that you use for reaction. More substrates for reaction, and then you can see the reaction rate. Substrate is something you can control, but reaction rate is not. So you can see substrate concentration is the independent variable to be put in the x-axis. And when we interpret graphs, the x-y axis meaning is really important. So when you face when you face a question during exam and tests, and you see it here, see these two graphs, they are showing the exact same reaction, but their graphs is totally different. You see it here, This one, the y-axis means the amount of product over time. So when the reaction goes on, when time goes on, and the amount of product increase, and then it starts to become steady. This one, we reach this horizontal line is because, okay, the meaning here is means no more product form. The product here may be, okay, I have 50 products, and then it does not increase anymore. That means that no more products form when the time still increase. This means the end of the reaction. So here, you see this one, same reaction, but this is reactant. So during the time passes on, the reactant initially, at first, we have so many reactants. We have 50 reactants at the first. And then when time passes, the reactant decreases, the concentration decreases until it reaches a horizontal line. This one means the reactant does not decrease anymore. And both of these indicates the end of the reaction, and these two are actually showing the exactly same reaction, but their curves are totally different. So when you look at the questions, you have to make sure that you know what this means before you can interpret the meaning of the graphs. And whenever sometimes I don't use product, maybe this one is, I change this one to reaction rate. So what does it mean now? If I change it to reaction rate, that means when time goes on, the reaction starts to become increasing, reaction rate increasing, and then it reaches the horizontal line. For this horizontal line, you put it here, maybe 50 something unit. There is reaction. But the reaction rate becomes stable at 50. So that is another meaning, because for the previous, this reaction, this horizontal line means the end of reaction, but for this graph, because I changed the y-axis, and the meaning becomes that at this point, we have 50 reaction rate, 50 units of reaction rate. There is reaction. So you have to be careful of the y and x-axis meaning. Okay, and the slope has its meaning too. Horizontal line's meaning, I've just talked about it. The slope's meaning, usually slopes means the rate of change. See, if this is just a straight line, means the slope is unchanged. So some things is unchanged. This one means directly proportional. When the enzyme concentration increases, the reaction rate increases, and they increase steadily. So this is the slope's meaning. But for this one, you can see the slope here is steepest, and then less steep, and then finally it becomes a horizontal line. Should be. It doesn't draw it here, but it should be a horizontal line later on. So the slope in here means the rate of change. Now between point A and point B here, you can see increasing from point A to point B causes a huge increase in the y-axis, means the reaction rate increases so much between point A and point B. So this means when the substrate concentration is very low, when you increase it a little bit, the reaction rate increases drastically. But as the concentration of substrate increases and increases, for example, we look at here, point C and point D, you can assume that these two and these two are the same distance. At point C and point D, when you increases the substrate concentration, you can see it here, the reaction rate doesn't increases any more that much. It is still increasing, but the rate of increasing becomes slower. So when you look at the slope, there is usually some kind of meaning. For a slope like this, for graphs like this, means something increases very fast at the beginning and it becomes stopped increasing. For some graphs like this, it's the same. Very fast at the beginning and then slows down and then it stops increasing or decreasing. But for slopes like this or this, means something is very slow in the beginning, because you see the slope here. Oh, why does it gone? Okay, the slope here is not very steep at the beginning, and then as time passes or as the reaction goes on, it becomes very steep. So you have to take a look at these two are a pair and these two are a pair, meaning these two means something increases very fast at the beginning and then slows down. These two means something increases very slowly at the beginning and then becomes fast. Okay? So, next one. Let's take a look at some examples. Say here is something I take out from the biology textbook from chapter 4. Sometimes we have to look at the slope. See the slope here? When we look at the graph, 25 degrees and 35 degrees, what are the difference? You can see the slope. This one is more steep than this one. And it levels off. This one doesn't levels off. So you can take a look at this. And these two, this one more steep than this one. So at the beginning, 35 degrees means faster reaction than 25 degrees. And then at the horizontal line, draw it to the y-axis. See here, accumulative amount of oxygen. This is the product. The product is higher for 35 degrees. Amount of product is higher for 35 degrees than 25 degrees. This is this meaning. And this one means slope of 35 degrees is steeper than 25 degrees, meaning that reaction rate of 35 degrees is faster than 25 degrees, and they reach the same equilibrium, means that they have the same amount of product at the end of the reaction. And how about this one? This one, they have the same slope at the beginning, meaning that 35 degrees and 25 degrees, they have the same reaction rate at the beginning, but their amount of product is different. For 35 degrees, you have more oxygen at the end of the experiment, and for 25 degrees you have less. So you interpret graphs by this way. You can know, and then of course you have to look at the question to see how you answer this question. Okay, so do it by yourself. And how about this one? This one, it asks with chemical X and without chemical X, and the amount of substance U. Substance U is the product. How does it difference? Now, of course, you have to look at the initial slope too. The slope means reaction rate. So without chemical X, reaction rate is faster than with chemical X, and they reach the same equilibrium. So it means that at the end of reaction, they have the same amount of product. And you can see the time when they reach the equilibrium. At this one, without chemical X, it reached the straight line at this point, but for this curve, it reached the horizontal line as this. So you look it back to the x-axis, means that this one actually, when it reaches the horizontal line, means the reaction has been stopped. So the reaction stopped at this point much earlier than with the chemical X added. This is also something that you can look at when you are interpreting the graph. So something that tells us that chemical X is not good for the reaction, because when you have the chemical X added, your reaction rate is slower and you need longer time to finish the reaction, although the amount of product is unchanged. So this is something that you can get from interpreting the graph. Okay, next thing I want to talk about is the best fit line. Sometimes we have plot the graph already using the correct x and y axis, but then we have so many dots. If we want to join them all together, you may get something like this, which is not a straight line at all. You can also see the trend. You can still see the trend, but it is not something we want. So at this point, we want to have a straight line, which shows us the correlation between the x and the y axis. But I just want one straight line. So I have to draw a best fit line. It is a line that stands nearest to most of the points. You have to look at all the points and you try to draw a line through the center of them. The line doesn't necessarily touch all the points, but it has to show the tendency where the point goes to. So for this one, actually I would draw, okay, of course use a ruler. I'm not using a ruler now, I don't have a ruler here. Just draw a straight line, go through most of the point, then it is okay. This is the best fit line. And some examples to see the best fit line is like this. So this is something draw using the Excel. You can see that some points we cannot go through all of them, but I can draw a line. This line is actually drawn by the Excel and to pass through most of the points. And sometimes when we have some extraordinary points, just omit it. For example, if I have a data point here and then I could not just take care of this one and omit all this one and draw the best fit line here more close to this one. This is not possible. This is not correct. If we have some extraordinary point, just omit it. This one is an extraordinary point. So you see that the best fit line actually doesn't consider this point. Some more examples for you. That see this one, these are actually extraordinary points. It's so far away, we just omit it. And this one, you can see that most of the points, they are not in place. You cannot take care of all of them, but usually you will not see these kind of graphs in your exam. It's too difficult for you to draw the best fit line. Usually what you have to draw is something like this only for your Form 5 and Form 6 SBA. Okay, is that clear? So this is all I want to talk about. If you have any problems, please be free to find me anytime. Bye.